This video is going to be about functions, so let's start with the definition of a function. Okay, a function is a relation between two sets and that's sets in the sense that we talked about in chapter 0. So a function is a relation between two sets such that every element in the domain so remember the stuff in the domain is what gets plugged into the function. So typically that's going to be x's for us. Every element in the domain gets mapped to exactly one element in the range. And that's going to be typically y for us. And here, this exactly one is what's important. For example, you can't have x get mapped, say you plug in 2 into a function. That can't go to 4 and to -4. That wouldn't be a function. A classic example is the birthday function. For instance, if you plug in a person into the birthday function, it spits out their birthday. Okay? So if I plug in John Doe and it spits out January 1st, no one has more than one birthday, so that's a function, right? I can't plug in John Doe and get January 1st and also May 1st, right? No one has 2 birthdays. On the other hand, it's perfectly fine to plug in John Doe and get January 1st and Jane Doe and get January 1st. That's 2 different x's going to the same y. That's totally fine. So this is the definition of a function. And now I also just want to do a quick review of the coordinate plane, the xy plane. So you've got your horizontal axis, that's the x-axis, and your vertical axis, which is the y-axis. And if you want to graph points, let's just choose a few. 1, 3, -2, 0, -3, 4, and 1, -5. So let's start with 1, 3. So you always get x comma y when you're dealing with ordered pairs. That's what these are called. So the first number represents the x value and the second number represents the y value. On the horizontal axis, right means positive, left means negative. On the vertical axis, up means positive, down means negative. And here we've got a scale for this thing which tells us that every tick mark represents 1 unit. So 1, 3, you always start in the center, at the origin it's called. So this is the origin. And the x value is 1, so we're going to go right 1. And the y value is 3, so we're going to go up 3. And here's our point, 1, 3, this little dot. Okay, let's try -2, 0. So we start in the middle again. The x value is -2, so we're going to go to the left 2. And then the y value is 0, which means we're not going to go up or down at all. So it's just going to lie on the x-axis here. That's this point. Maybe I'll draw little label arrows. -3, 4, so again you start in the center. -1, 2, 3, that's our x. +1, 2, 3, 4, that's our y. All right, so this is how you graph these pairs. And so 1, -5, our last one. X is +1. -5 is the y value. So something like this. And again, these dots are the actual points themselves. These labels are not, just sort of explaining which is which. And in general, the coordinate plane is broken up into quadrants. So this one in the upper right-hand portion is quadrant number 1. That's because this is where both x is positive and y is positive. Then there's quadrant number 2, and we're just going to sort of work our way around counterclockwise. This is quadrant number 3, and this is quadrant number 4. And this point in the middle, 0, 0, is called the origin. So that's just a brief review of the coordinate plane in case you haven't seen it in a while. And then there's one more thing I want to talk about with respect to functions, and that is the vertical line test. Specifically the vertical line test for y as a function of x. This is not true when you're talking about x as a function of y, but in general we like to talk about y as a function of x. So if you have the graph of an equation, so for example, is y equals x squared a function? If you know what the graph looks like, here we've got this graph in teal, the vertical line test says that any vertical line you can draw, okay, so you can imagine this vertical line, and this vertical line, and this one, and I'm just choosing a few at random, but really it should be true for literally any vertical line you can draw. So if you've got a piece of paper in front of you, you can imagine holding your pen or pencil vertically and sort of moving it across the function. And the vertical line test is, if every vertical line intersects the graph in only one place, or in no places, then you do have a function. So you can see here, maybe I'll draw another one here, right? All these vertical lines, some of them hit the green portion of this graph, right? And some don't, and that's fine, but there's never a vertical line that hits it in more than one place. So in this case, yes, this represents a function. Because remember, the definition of a function is that for every x, it can only get mapped to one y. And that's what we're doing when we check this, right? You choose an x, that's what the vertical line represents, a specific x value, like say this is the x value 3. And then for the x value 3, it can only hit your function in one place, right? Meaning there can only be one y value that goes with 3. So let's look at one more. Is x equals y squared a function? And we can see this time, right, if I choose my vertical line here, again, let's just say this is 3, now it's going to hit my function in two places, right? So there are two different y values, whatever this y value is and whatever this y value is, and those both correspond to the x value 3, and that's no good. So if you have the graph of a function, the vertical line test is a quick way to tell you whether or not you're dealing with an actual function. And remember, it should be true for any vertical line. Like if you can find even one, then you know immediately it's not a function. Even one is enough to prove that it's not.